Hey everyone, today we're going to solve a quadratic inequality. We're looking to solve for which x values make this inequality hold, okay? So on one side we have x squared minus 5x, and we want to know what x values, what interval, what range of x values would make that expression strictly greater than the value of -4. So we're going to use a similar strategy to the one we use to solve quadratic equations, which is to set one side equal to 0. So I'll put that in brackets. We typically set one side equal to 0. Now, obviously, the right-hand side is easier to do that with, and so I'll add 4 to both sides to get rid of it on the right-hand side. And so now our inequality says that x squared minus 5x plus 4 is greater than 0. Now, if I can ask you to picture what that looks like on a graph, we can make a very crude graph for this parabola. First of all, it's going to be an opening up, right side up parabola, a smiley parabola, as I tell my students, because of the positive x squared coefficient. We can factor this left-hand side. This factors as x minus 4 times x minus 1, right? Two numbers that simultaneously add to -5, multiply to +4, or -4 and -1. And so now this is really what we have. And this tells us that we have roots. If, again, roots are where the y coordinate is 0. And so if we consider this left-hand side to be a function, right, we could solve the equation 0 is equal to x minus 4 times x minus 1. And this would give us solutions x is equal to 4 and x is equal to 1. And so that means that we have roots at 1 and also at 4. And since this is again, right side up parabola, a smiley parabola, and we can also see the y-intercept at 4, that's kind of given to us. This is going to look something like that, right? Very crude graph, crude sketch, but this is roughly what it's going to look like. It's going to open up, it's going to have roots at 1 and 4, y-intercept at 4, and it's going to go up and towards both directions, really. And so if we want to know what intervals in x satisfy this inequality, what we're really looking for is when is that parabola above 0, right? Above 0 in the y coordinates, obviously. And so that's analogous to saying, when is this parabola, when is this function above the x-axis, right? In the positive y coordinates. Right? So where is that the case? We can make a number line, which is something that we typically do in x. So we can make a number line with the roots at 1 and at 4. And we can number line because we can make from that a sign diagram from -infinity, let's say, which is somewhere all the way over there, all the way up to +1. This function goes through positive y coordinates, right? The y coordinates are always positive all the way until we reach that root. And so from -infinity all the way up to +1, our function is in the positives, right? At the root, the function is at 0, which is neither positive nor negative. But between 1 and 4, below the two roots, we're in the negative y values, right? And so the function itself has negative values between our two roots. See that it's below the x-axis in the negative y values. And then again, once we cross the root at 4, we're back into the positive y coordinates, back into the positive y values. And so from 4 all the way through to +infinity, we have positive values for our function. And so with this sign diagram, that's a term you'll likely see frequently moving forward. Looking at this sign diagram, this function is above 0, i.e. positive, from -infinity, which we kind of don't write, all the way to +1, and from 4 all the way to +infinity. Now, careful, this is not greater than or equal to, right? This is strictly greater than, and so we're not going to include the 1 and the 4. We're not going to include the roots, because at the roots, our function is not positive. It's 0, and 0 again is not positive nor negative, is simply 0. And so we don't want to include the 1 nor the 4. And so we can write our solution for x in set notation or in interval notation. In set notation, we would write our solution to this inequality. Again, this is going to be an interval of values, right? There's no one or two specific values. This is true for a bunch of different x values. So we're going to write our answers as intervals. So we can either write it in set notation as x such that x can be less than positive 1, or x can be bigger than positive 4. Either or would suffice, right? As long as x is less than positive 1, to the left of 1, our function is in the positives. And if x is to the right of positive 4, our function is also in the positives. And so we can say any x value such that x is strictly less than 1, or x is strictly greater than positive 4, and from there x can be any real number, okay? So this is one way of writing it in set notation. In interval notation, if that is something that you are more familiar with, we could write this as the union of two intervals. The union of the interval from negative infinity to positive 1, and the interval from positive 4 to positive infinity. Union because the union of two sets means either or both. And so that is the case. Well, I guess we can't really be in both, but yeah, either or would suffice in this case. So in interval notation, we say x is bound to the interval of, or is in the interval of, or however we're going to read that, is in the interval from negative infinity all the way to positive 1, round bracket because we're not including that endpoint. Again, we're not including the positive 1. Our function is not above 0 at positive 1. It is 0, which is not positive. So don't include the positive 1, round bracket, union, round bracket again, this time positive 4, all the way to infinity. Round brackets always when we touch the infinities because we never actually get to infinity or negative infinity. And so negative infinity to 1 or 4 to infinity. Any x value in those intervals would make this inequality hold true. And that is how we solve quadratic inequalities. So again, set notation or interval notation, whichever one you prefer, both are perfectly fine. Hope this helps, and thanks for watching.